These are our Algebra 1 notes for 3.5, solving equations with variables on both sides. So this is all about ratios, is what we're working with. So a ratio uses division to compare two quantities. You're going to write them as, and there's different ways here. You can write as A to B with words. You can write as A and then a colon and then B, or as a fraction. And we really prefer the fraction one because it's going to be easier to reduce and work with, because we are going to want to simplify ratios just like we would simplify a fraction. You read it as the ratio of A to B. That's the proper way to read them. So you have worked with ratios before. This first example is pretty simple. It's going to maybe be a throwback to like 6th grade or 7th grade or something, but it's a good place to start. We want to start with things that we already know about ratios, and then we'll work into solving proportions. So we have a pet store. There's 10 kittens and 6 puppies. We are finding the ratio of cats to dogs. So whatever they say first, remember we're writing these ratios as fractions, is going to go on the top, and the second one is going to go on the bottom. So we're going to write this as dogs over cats as a fraction. And that's going to be, let's see, how many dogs do I have? I have 6 dogs and I have 10 cats, so 6/10. And then I do want to reduce that and make it 3/5. So our ratio is 3/5, or 3 to 5 would be another way to say it. But our ratio of dogs to cats is 3 to 5. Now we want to know cats to the total number of dogs and cats. So total would be how many we have all together. Total means we're taking a sum, so that's going to be 10 plus 6, 16. So if we want, let's see, cats to total, that means cats on top, total on the bottom. And so our cats are 10 kittens here, and our total is the number we just found, 16. And then we would want to reduce that and write that as 5/8. So now we're looking at proportions. So a proportion is when we have two equal ratios or two equal fractions. There's no words on this one, so we don't really know what they're talking about. We don't know if it's some kind of word problem, but we do have two equal ratios. So one way to solve those that always works is to do the cross products. So I'm going to multiply W times 7 and 4 times 25. So W times 7 equals 4 times 25. So we're multiplying those cross products. And the product here, the W times the 7, is equal to this product. So remember, product means multiply. So this is going to be 7W equals 100. Divide by 7. W equals 100 over 7. So this is a way that always works, but it might not always be the easiest way. So if you look at this one, if I think about this as just two equal fractions, I might look at from the 2 to the 12 and say, well, all I have to do is multiply by 6. If these fractions are equal, if I multiply by 6 on the top and bottom, that would give me 12ths. So then what that means is 6 times 9 is going to equal m. So if my denominators are equal, my numerators have to be equal, which means 54 is equal to m. So the other way, if you wanted to do cross products, right, is you could multiply the 9 times 12 and the m times 2. And you can see this way is a little bit more mathy. I have to know 9 times 12. Not everybody knows that. M times 2 is 2m, and then I'd have to divide. So it's going to be easier for you if you can find some kind of a pattern and work them out that way instead. So that's really what we want to do. And you're going to show me that you understand what that pattern is by writing in something like this, like what you're multiplying by, and just doing a short equation. So we do want to still use algebra to represent that pattern. We don't want to just write down a number answer. So on this one, I have z 54ths is equal to 5/9. And again, I have two equal fractions. I have two equal ratios. And so I might try to see, is there a way to go from like the 9 to the 54? So I always want to look at just the ones that have numbers and try to figure out what's going on. So I'm seeing that if I multiply 9 times 6, I get 54. So then I must have to also multiply by numerator by 6. And so z is going to equal 5 times 6, which means z is going to equal 30. So if I was going to do cross products here, I would multiply the z times 9. I always put a line through my z so you can tell it's not a 2. And the 5 times 54. And again, this way, like I have to multiply 54 times 5. That's mathematically going to be a lot more work. That's going to be, let's see, 5 times 50 is 250. And then 5 times 4 is a 20. So this is going to be 270. So 9z is equal to 270. Divide by 9, z equals 30. So now you're probably wondering, if it's so easy to find this pattern, why didn't you do that on the first problem? And if we look at the first problem, the numbers we had to work with were 25 and 7. There's nothing I can take 7 and multiply by to get 25. So sometimes you do have to use cross products. And we're going to learn more about cross products tomorrow. But it should be something that you've seen before. All right, so now we've got to do the work where we're going to take these ratios, write them as a proportion. So that means 2 equal ratios, and then solve. So I see this part here, 6 is to 20. So that's going to give me one of those fractions or ratios. As means equals. And then we have x is to 70. So remember, the one that's first is going to go on top of the fraction. So I have 6/20ths equal x 70ths. And then I know you might be thinking, well, there's nothing I can take 20 and multiply by to get 70, but sometimes we can reduce fractions first, and then that helps. If nothing else, it's going to make the number smaller. So if I reduce this, I would get 3/10 equals x 70ths. And now I can clearly see, if I take 10 and multiply by 7, that's going to give me the 70. And if I multiply by 7 in the denominator, I need to multiply it in the numerator as well. So 7 times 3 is going to equal x, which means 21 is going to equal x. So we don't want to do cross products unless we have to. If I was going to do cross products, right away I would have done 6 times 70 equals x times 20. And again, the numbers in this are a lot bigger. It's going to take longer to work this out, but I do get the same answer. So we should always get the same answer. We should be showing math the way you show math. So there might be more than one way to work a problem, but there's really just one way to show math work. On the last one, we have 18 is to 15 as is my equals, y is to 50. So 18 is to 15, that's going to be a ratio. So I'm going to write a fraction with 18 on the top and 15 in the denominator, equals y is to 50 means y is in the top of my fraction and 50 is in the denominator. So I can't take 15 and multiply by anything to get 50. 15 times 2 is 30, times 3 is 45, times 4 is 60. I can't make that work, but I could reduce this first again. So I'm recognizing I could divide the top and bottom by 3, right? If I divide by 3, I'm going to have 6/5. And now I can see, if I just take the 5 and multiply by 10, I'll have 50 here and 50 here, which means I also have to multiply the numerator by 10, which means 10 times 6 is equal to y. And so 60 equals y. And once again, if we look at our alternative way, I would not work this out 2 ways on my homework, just do it 1. This way, man, I don't even want to multiply 18 times 50. That's going to be like, well, 50 times 10 would be 500. And then we've got 50 times 8. So I don't even know. That's going to be really ugly, isn't it? So I think the whole goal here is that we want to be thinking about doing things the easiest way, right? I don't want to be doing things the most difficult way. You could even reduce and then multiply. Like that would work also. All right, so let's go ahead and finish this off with our second method. So 18 times 50 is going to be 900. I guess I need to write it first. 15y times 15. Okay, so 500, 400. So 900 is 15y, and then divide by 15. So I know 15 divides into 90 6 times. And so this is going to be 60. So we do get the same answer. But again, like, this is a much better method. That's what we want to see you doing on your homework. So you could do cross products, but don't get too carried away. Don't worry about that too much. So this is the end of our notes. Please let us know if